Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell, then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you'll see the links for the O-level and the A-level group. Welcome back, friends. Tunaendelea na mfululizo wa vipindi vya Advanced Biology Coordination, na hichi ni kipindi cha 18 kwenye ile mfululizo. Na kama mfuatia kipindi kilichopita, nilikuwa nafundisha kuhusu all or nothing law, kuhusu kwenye properties za nerve impulse. Kwa hiyo properties za action potential. Na hapa tunaendelea na properties nyingine za action potential. Endelea na properties nyingine za action potential. And in this session we are going to discuss about the speed of conduction. So the speed of conduction of nerve impulse ni kwamba nerve impulse inapokuwa inapita kwenye axon inakuwa inapita kwa speed fulani, na hii speed inakuwa affected by different factor. So once an action potential has been set up, it moves rapidly from one end of the neuron to the other. This is the nerve impulse. Movement of the action potential is the nerve impulse. Now the speed of nerve impulse varies in different fiber and animal. So kuna factors za nerve cell ambazo zina affect conduction, lakini pia kuna factors za animal mwenyewe ambayo nerve cell ipo zina affect conduction. So according to the precise nature of the neuron, transmission speed vary from 0.5 meter per second to over 100 meter per millisecond. Sio per second, it is per millisecond. So kuna three important factors ambazo zinadetermine the speed of conduction of nerve cell. Three important factors ambazo kuna temperature, kuna diameter of the axon, na kuna Myelin sheath. Lakini before going to discuss about the factors which determine or which affect the speed of conduction of the nerve cell, let's discuss a little about the evolutionary adaptation of the neuron structure. Evolutionary adaptation of the neuron structure. Manake neuron ilivyotengenezwa mwanzo kabisa ni kwamba tunajua animals zina undergo evolution. Tulianza na single cell according to the concept of evolution. Tulianza na single cell organisms such as bacteria and prototysts, then zika differentiate, ndio baadaye tukaja tukapata hata tulivyotoka kwenye bacteria, tukaja kwenye prototysts, tukaja kwenye fungi na plants, then tukaja tukapata animals ambao ni most advanced. Kwa hiyo ninachokisema ni kwamba the rate at which axons within nerves conduct action potential govern how rapidly an animal can react to danger or opportunity. Kwa hiyo manake inategemea sasa adaptations zilivyokuwa zinatokea kwa wanyama ndio kwa wanaangalia ni kwa kiwango gani wanaweza react. Moto ukitokea wanawezaje waka draw their hand. Simba kitokea wanawezaje kukimbia haraka. As the consequence, natural selection often results in anatomical adaptation that increase conduction speed. Hiyo natural selection. So one such adaptation is wider axon. Hiyo ni moja kati ya adaptation. Tutaenda kusoma mbele kwenye diameter, lakini wider axon, yani zile zenye diameter kubwa zina conduct impulse faster kuliko zile zenye diameter ndogo. In the same way that a wide hose offers less resistance to the flow of water, kama vile ambavyo unajua kwamba bomba likiwa pana maji yana flow kwa urahisi kuliko bomba likiwa jembamba, than does a narrow hose. Pia a wide axon provides less resistance to the current associated with action potential. Wider axon, manake ile axon ambayo ina diameter kubwa inakuwa ina resistance ndogo kwa current ambayo inakuwa associated na action potential. Kwa narrow axon manake zitatengeneza impulse ambayo itakuwa ina speed ndogo, wakati wide axon itakuwa na speed kubwa. So in invertebrates, Kwa wanyama ambao hawana uti wa mgongo, the conduction speed varies from several centimeters per second in a very narrow axon to approximately 30 meters per second in a giant axon. Kwa ukisikia neno giant axon, maana zile axon ambazo ni nene, zina diameter kubwa. Giant axon of some arthropods and mollusks. Kwa arthropod hawa ni kama viola na mollusks ni kama konokono wale mollusks. Kwa hiyo ndo jinsi ambavyo the speed of conduction ina vary with the diameter. The giant axon, they transmit nerve impulse at a very fast speed as compared to the narrow axons. Lakini kwenye vertebrates, yani wanyama wenye uti wa mgongo, vertebrates axons have narrow diameter. Zenyewe ni narrow, ni nyembamba. Asa if they have narrow diameter, zenyewe zina conduct vipi impulse fastest, but can still conduct action potential at higher speed. Now the question comes, how is this possible? How is this possible? Kama tunajua kwamba they are narrow in diameter, inakuwaje zinakuwa zina uwezo tuna conduct nerve impulse faster? So our answer lies kwenye nini? Evolutionary adaptation again. So adaptation itokea that enables fast conduction in the vertebrate axon is electrical insulation. Kwa wali insulate zile axon, wali insulate kama vile ambavyo huo kwenye nyaya tunakuwa tunaweka plastic nje ili insulate, na ile pale huwa ina act kama beli ya high conductor electricity. Kama waya ni umeme, ile kushika nje huwa hauku affect. Kwa sababu gani? Kule kuna plastic pale nje. Kwa hiyo manake pia axon zilifanya insulation analogous to the plastic insulation that encases many electrical wires. Pia nerve cells of the vertebrates zimefanya insulation hivyo. So insulation causes depolarization current associated with the action potential to travel faster along the axon interior, bringing more distance region of threshold sooner. Kwa hiyo insulation inachokifanya ni kwamba kama action potential ikitengenezwa hapa, kama action potential ikitengenezwa at this point, let's say we have our axon. Ngoja nichole hapa, nachora tu hapo kuelekeza ili uweze kunielewa, lakini we'll explain this more later. So let's say we have this is our axon, then assume our action potential is made here. Assume our action potential is made here. So if our first action potential is made here and we have the Myelin sheath, Myelin sheath ndio ambayo imetengeneza insulation. So let's say imetengeneza insulation, and this is the axon membrane. Kwa tuseme hiyo ni axoplasm. Let's say tuseme upande wa pili our axon membrane ni hapo. So huku pia tuna Myelin sheath imetengeneza insulation. Myelin sheath hapo imetengeneza insulation. Myelin sheath imetengeneza insulation hapa. Kuna node fulani vile, kuna node fulani vile. So if this is the Myelin sheath now, how does the nerve impulse is conducted faster? If the action potential is developed at this point, which is called node flanvel, and this is the node flanvel again. This is the node flanvel again. Now the nerve impulse can travel from here, jumps to this point, and then from this point it jumps, action potential jumps to this point, and then action potential again jumps to this point. So in this membrane also what happens is the same. So the formation of the local circuit now will be from here to here, and from here again the local circuit will be formed up to there. From here again the local circuit will be formed up to there. So you see the length of the local circuit formed is longer, and this kind of conduction we call it as saltatory conduction, because the action potential tend to jump in Greek we call it as saltaire. So saltatory conduction simply means it is because of jumping. It comes from the Greek word saltaire, means jumping. So what we are concluding is that insulation causes depolarization current associated with action potential to travel further along the axon interior, bringing more distant region to the thyroid sooner. So the electrical insulation that surround the vertebrate axon is called Myelin sheath. Kwa insulation ambayo ina surround hapo inaitwa Myelin sheath. Kwa hiyo I hope this is not the new terminology kwa sababu tumeshai discuss sana huko nyuma. Myelin sheath are produced by oligodendrocytes kwenye central nervous system na inakuwa produced na Jiunge cell kwenye peripheral nervous system. During development, these special glia wrap the axon in many layers of the membrane. The membrane forming these layers are mostly lipid, which is a poor are mostly lipid. Kwa hiyo kwenye hiyo insulation ni kwamba inakuwa formed na lipid, na lipid ni poor conductor of electricity. Ndio maana hiyo action potential huwa haiwezi kuwa formed everywhere. So they are mainly made of lipids which are poor conductor of electricity. So in myelinated axon, voltage-gated sodium channel are restricted to the gaps in the myelin sheath called nodes of Lanvin. So zile sodium channels zinakuwa kwenye nodes of Lanvin peke yake. Kwa hata action potential inaweza kutengenezwa kwenye nodes of Lanvin peke yake. Furthermore, the extracellular fluid in the contact of the axon membrane only at the nodes. As in that, action potential are not generated in the regions between the nodes. Rather, inward current produced during the rising phase of the action potential at one node travel within the axon all the way to the next node. Kwa maana nasema ina jump kwa sababu gani? Electrical signal au local circuit kitengenezwa at one point ina jump all the way to the next point. So there current depolarizes the membrane and generates action potential. Kwa ikifika kwenye another node inatengeneza tena action potential. So action potential propagate more rapidly in myelinated axon because the time consuming process of opening and closing ion channel occur at only a limited number of positions along the axon. Kwa kile kitendo cha kutumia muda ku open na ku close sodium channel kina occur only at some points, and this mechanism of propagation of action potential is also called saltatory conduction, from the Latin word saltaire. Saltaire means to leap or to jump. Leap ni kama small jumping, yani short jumping kama unazofanya puns. Kwa short jumping 1 meter 2 meter, that is leaping. Lakini kwenye axon huwa haiwi 1 meter, inaweza kalip labda few centimeter according to the anatomy of that axon. Kwa hapo nadhani utakuwa umeelewa adaptation mbalimbali ambazo neurons zinakuwa zina undergo. Unaona hapo anasema kwamba the major selective advantage of myelination is it is space efficacy. Space efficacy maana yake nini? Tunakuwa tumesave space kwa sababu tumeshakwambia kwamba myelinated axon inakuwa na diameter ndogo. Diameter yake inakuwa ndogo lakini bado inakuwa na speed kubwa. Ni tofauti na kwenye giant axon. Giant axon ni kweli zina speed kubwa lakini diameter yake pia inakuwa kubwa kwa zina occupy space. Lakini kwenye myelination diameter axon inakuwa ndogo lakini zina occupy space ndogo lakini zina uwezo ku conduct impulse faster. Kwa mfano, a myelinated axon of 20 micrometer in diameter has a conduction speed faster than that of a squared giant axon with the diameter of 40 times greater. 40 times greater manake 20 micrometer 2 times na 40 40 times greater 2 times na 40. Afu tuangalie hiyo giant axon. Wakati huo unakuta hii ya 20 micrometer diameter ina conduct impulse faster kuliko ile mwenye diameter mara 40 yake. Kuna kuja kugundua kwamba kuwa na diameter ndogo tuna save space. So consequently more than 2000 of those myelinated axon can be packed into the space occupied by just one giant axon. Huyu hapa mwenye diameter kubwa giant axon akiwa mmoja, huku kwenye myelinated tunakuwa na ngapi? 2000 axon. Kwa unaweza kuona jinsi gani tuna save space, na pia axon zikiwa nyingi zinasababisha pia speed ya conduction iwe kubwa, sensitivity iwe kubwa, kama ambavyo tutaenda kusoma huko mbele kuhusu mambo ya sensitivity. So for any axon myelinated or not, conduction of action potential to the end of the axon set the stage for the next step in the neural signaling, that is the transfer of information to another cell through the synapse. Kwa conduction kwenye axon ikifika to the end of the neuron, pale huwa ina prepare the stage ya nini? Synaptic transmission. Kwa nadhani tutakuwa umeelewa kwa nini animals wengine wali undergo myelination, kwa nini wengine wali develop giant axons, na nadhani hata tutakapoenda ku discuss about factors affecting the speed of conduction of the nerve cell itakuwa rahisi sana kuelewana. So in this session I am ending up here, and in the next session we'll be discussing about the Myelin sheath. Don't forget to subscribe and to share the link of the video to your fellow students so that they access this video. Thank you everybody. Nice studies.